Good morning, teachers, and welcome to another episode of Experiments with ScienceBus of Wacebo. Today, we are going to thoroughly examine the acoustics kit. This specific kit allows us to delve into the exploration of the propagation of mechanical waves. Today, we shall conduct several experiments on the propagation of acoustic waves, which are a type of mechanical wave. This educational experience is well suited for primary school students, but it can also be effectively utilized with lower secondary school pupils to introduce this topic. To successfully conduct this particular experiment, we shall necessitate the tuning fork, the wooden stick, and the glass beaker, all of which are encompassed within the kit that we have provided. As a first observation, we must make our students understand that the vibrating tuning fork is our source of sound waves. So first of all, let's conduct some tests and strike the tuning fork with the wooden stick several times, perhaps using different intensities and forces. By explaining in this manner, we assist our students in comprehending that a vibrating tuning fork generates sound waves that propagate through the air and eventually reach our ears, which are capable of perceiving them. The subsequent notion to convey to students, especially those in primary education, is that these sound waves we perceive with our ears are indeed a tangible physical phenomenon, something quantifiable that we are able to observe. If air appears too abstract as a medium for the propagation of sound waves, making it somewhat difficult to fully comprehend, we can opt for an alternative medium, such as water, instead. Therefore, let us proceed to take our glass beaker and fill it to the halfway mark with water. Alternatively, we have the option to utilize the sink available on our ScienceBus. Upon successfully filling our glass beaker with the required amount of water, we proceed to initiate the vibration of the tuning fork once again and carefully submerge the prongs into the beaker. What we will notice is that the tuning fork, when set into vibration, has propagated its sound waves both in the air and through the water. In fact, sound waves are mechanical waves and must always travel through a medium, which can be air or, in this case, water. We repeat the experiment several times by striking the tuning fork with varying intensities, to demonstrate that if I strike it hard, the ripples generated on the surface of the water will be numerous, whereas if I strike it gently, I will barely see small ripples. You might have your students replicate this simple experiment, perhaps by substituting the glass beakers with plastic cups, and you can entertain them by allowing them to try striking the tuning fork with varying degrees of force, causing the water to ripple and even vibrate out of the cup. In the upcoming videos, we will explore the physical characteristics of these waves, which today we have understood to be a real physical entity that exists and can be measured. So keep following us and see you in the next episode of Experiments with the ScienceBus.